Let's now continue with the level 1 challenge. So it's called Fallback, and it says look carefully at the contract's code below. You'll beat this level if we claim ownership of the contract and if we reduce its balance to 0. And things that might help you achieve this, you need to learn how to send Ether. So you need to interact with the ABI, see the ABI, how to send Ether outside of the ABI, how to convert from Ether to WAY, and you need to learn about fallback methods. So before I show you the solution, you can look into these things and try to solve this challenge because this is the easiest challenge. And to start off, click on Get New Instance. So let's look at the source code first. First, we are importing from this OpenZeppelin library, specifically the SafeMath contract. This will help us to avoid overflow and underflow because in any version under 0.8.0 in Solidity, whenever math calculations are done, whenever we have arithmetic, we can have underflow and underflow. So this is what we're doing, and we're just saying we want to use SafeMath for uint for all the variables of this type. Then we have contributions mapping. This just maps address to amount that it has contributed. We have the owner of this contract. We have a constructor, which is a function that gets called only once when you deploy the contract to initialize the contract state. It initializes the owner to the person who deployed the contract, and it says this owner will have 1000 Ether of contributions. Then we have a contributed function, so I'm going to skip this. Contributed function that allows you to contribute it. It is required that you need to pass in less than 0.001 Ether, so you need to provide less than this amount to contribute, and then it will add your, basically it will track that you have contributed, and it will check if your contributions are greater than the owner, then you'll be set as the owner. But this isn't how we exploit this contract, because we need to call this like 100 million times, so we have more contributions than the owner. So this is not really an option. Then we have a get contributions function that just gets the amount of contributions you have. Another way to do this is to just call, since this is public mapping, you can just call contributions with your address. Then we have a withdraw function. This is what we'll call after we get ownership, claim ownership of this contract, because it has this only owner modifier. What does this modifier do? Well, this is just some code attached to this function that gets executed before this code. So first, usually we put required statements in these modifiers. We're requiring that the caller is the owner, and if it's not, we're just going to revert the transaction. If this is true, then we'll execute the code of the function. Basically, this underscore is a placeholder for the function this modifier is attached to. And in this withdraw, we just transfer all of the contract's balance to the owner. Then we have a receive function. This is a function that every contract should have to be able to receive Ether. There are other ways, but I'm not going to go into them, so we'll keep this simple. So this function requires that you send at least some value to it, and your contributions are greater than 0, and then you get the owner. So it seems like if we can trigger this code, if we can send more than 0, if we can send some Ether into the contract, even if it's one way, and if we can get us to have some contributions, we'll be the owner. How can we do this? Well, let's solve this part first. So we can contribute it by calling this function. So open up the console and let's call this contributed function. By the way, you can interact with this contract. This is deployed to the ringbit testnet. So if we go ahead and say contract.address, look up this address on the ringbit testnet, you can see this is a real contract. To interact with this contract, you can verify this contract source code and interact with this contract through Etherscan. I wasn't able to do this, I don't know why, but you can of course interact through the console as you are supposed to. You can also interact with this contract using this like service. So this basically allows you to call any contract. It's very simple. You just paste in the address, and I've tried and succeeded in interacting with this contract using this method. So you just select the method type. It's either payable, view, or non-payable. Type in the method name, how much Ether you want to send, and just click on send. So you can solve this challenge by interacting with this contract using Leica. Just want to share it, but I'm going to interact with it the old traditional way through the console. So to contribute it, you have to say contract.contribute, and you can see we have a requirement statement that we have to pass. So we have to send less than this amount of Ether. So let's use this two-way function. Because contracts only accept way, we need to convert this Ether to way, and I believe this needs to be string. So we need to send less than this amount. This is in way. So let's go ahead and say await contract.contribute, and we need to send some Ether, and I believe you send Ether by just providing this object here and saying value, and then passing in less than this amount. So you can just pass in 1, I believe. So this transaction has finished. So we have successfully contributed, or have we? So how can you check this? Well, you just call the contributions mapping, because since this is public, you can just access it by doing await contract.contributions. Also pass in your key, the mapping key, which is an address, and we can access our address by saying player, and we can see we get this output here. If we go into words, you can see we get 1. So it means we have contributed 1, only one way. If we contribute again, for example, something like 8-way, if we check the contributions into words, now we can see we have 9. So we have already contributed. Now let's try to send some Ether into this contract, and we should be able to claim the ownership. How can we send Ether to this contract? Well, you can just expand MetaMask. Just click on send, paste in the contract address here, and you can get the contract address by saying contract.address. You can copy this and send Ether this way, or you can do it through the console by saying await contract dot send transaction. This is how you do it inside Web3, and we're using Web3 here, I believe. Inside these square brackets, you want to again say value, and we need to pass in more than 0. So I think 1 is fine. I think it should work, but this needs to be string. And before we do the transaction, let's see who the owner of the contract is now. And we can do this by saying contract.owner. And if we see through the contract, we don't have this owner variable, or actually we do have this owner variable, and it is public, so we can see it. And make sure you use await here. This is the owner of the contract currently, and that's definitely not me. So click on confirm. Let's see after we send some way if we can claim ownership. And the important lessons from this challenge is to learn how this receive function works and how it is triggered. So basically just sending money to this contract will trigger this function. And you can send this, as I said, just originally through MetaMask. Just click on send, paste in the contract address. So the transaction was mined. Now let's see who the owner of this contract is, and boom, that's my address. So we've claimed ownership. Now all I have to do is withdraw all the balance, all the money. So click on contract.withdraw, confirm the transaction. So this is a very simple challenge. You will just learn how to send Ether through the console in this contract. We've just learned how to call a function called the withdrawal function. We've seen how you can convert Ether using this two-way function. You can also use a ETH converter, I believe, any converter online. And after this is done, if you believe you have solved the challenge, you just go ahead and submit instance, and this should tell you if you have succeeded. And as you can see, we get an output like this into the console, and we get this check mark, which means we have completed the challenge. Congrats!